Very good morning, students. Today we are going to discuss 10th mathematics geometry important problems, nothing but riders, based on BPT, basic proportionality theorem, and its converse. Before going to start the problems, we recall the BPT and its converse. Let us see what the BPT is. In a triangle ABC, if DE is parallel to BC, then AD by DB is equal to AE by EC. And also other results, if DE is parallel to BC, you can write DB by AD is equal to EC by AE, and AB by DB is equal to AC by AE, and DB by AB is equal to AE by AC. Let us see the converse of BPT theorem. In a triangle ABC, if AD by DB is equal to AE by EC, that means if a line divides the two sides in the same ratio, nothing but AD by DB is equal to AE by EC, then DE is parallel to BC. And also if these conditions satisfied, then also you can say DE is parallel to BC. So everybody please recall that if a line parallel to one side, it divides the other two sides in the same ratio. That is basic proportionality theorem. If a line divides the two sides in the same ratio, then the line is parallel to the other side. This is called converse of the basic proportionality theorem. Now our first rider is, in a triangle ABC, DE is parallel to BC is given. AD by DB is equal to 3 by 5. AC is equal to 5.6. They are asking to find AE. I take AE as X. Now I am going to solve this rider. DE is parallel to BC. This is given. Then in a triangle ABC, if DE is parallel to BC, from basic proportionality theorem we can write AD by DB is equal to AE by EC. Therefore, AD by DB is equal to AE by EC. That is from basic proportionality theorem. Now you see AD by DB you can write as 3 by 5 is equal to AE is X by EC you don't know. You can write EC as AC minus AE. So you write AC minus AE. The next step, 3 by 5 is equal to X by AC is given as 5.6 minus AE we took as X. Now do the cross multiplication. First you multiply these two. 3 into 5.6 minus X is equal to, next you multiply this, X into 5, 5X. This 3 into 5.6, 16.8, 3 into X, 3X, that is equal to 5X. So 16.8 is equal to 5X minus 3X becomes plus 3X. So 16.8 is equal to 8X. You can write 8X is equal to 16.8. X is equal to 16.8 by 8. If you cancel, you will get 2.1. So X is equal to 2.1. Coming to second rider, children. In the given figure, LM is parallel to AB, AL is X minus 3, AC is 2X, BM is X minus 2, BC is 2X plus 3. They are asking to find X value. Again you see here, in triangle ABC, LM is parallel to AB, that is given. According to basic proportionality theorem, if a line is parallel to one side, then you can write CL by LA is equal to CM by MB. CL by LA is equal to Cm by Mb. Now you see Cl you don't know, La you know x minus 3, Cm you don't know, Mb you know x minus 2. So what I am going to do here is, this is from basic proportionality theorem. What I am going to do here is, I am going to write this equation in terms of known things. That is, Cl we can write as AC minus La, AC minus La, by you write La as it is. Again this Cm I can write Bc minus Bm, Bc minus Bm or Mb by Mb. Now you see AC is 2x minus La is x minus 3 by La is again x minus 3, Bc is 2x plus 3 minus of Mb is x minus 2 by again Mb is x minus 2. Now 2x, if you remove this bracket, minus x plus 3 by x minus 3. Again this is 2x plus 3, if you remove this bracket, minus x plus 2 by x minus 2. This is x plus 3 by x minus 3. This is x 3 plus 2 plus 5 by x minus 2. We do cross multiplication here. Multiply these two first. X plus 3 into x minus 2 is equal to, multiply these two next, x plus 5 into x minus 3. You multiply these two, x square minus 2x plus 3x minus 6. In the same way, x square minus 3x, 5 into x, 5x, 5 into minus 3, minus 15. So it become x square plus x minus 6. Here it is x square plus 2x minus 15. This both gets cancelled. Now x plus 2x you transpose here, minus 2x, there minus 15, minus 6 you transpose here, plus 6. It is minus x, this is minus 9. So minus minus you can cancel on both sides, then x is equal to 9. Coming to the very important rider, prove that a line segment or line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. This we have to prove using BPT theorem. You see children, take a triangle ABC. What is given? In triangle ABC, D is the midpoint of AB. That means AD is equal to DB. And also DE is parallel to BC given. What you have to prove? This DE bisects AC. That means AE is equal to EC you have to prove. Let us see the proof. In triangle ABC, DE is parallel to BC. That is given. Children, in any triangle, if a line is parallel to BC, you can write it divides the other two sides in the same ratio, nothing but according to BPT theorem. That means we can write now AD by DB is equal to AE by EC. So AD by DB is equal to AE by EC. This is according to basic proportionality theorem. But AD is equal to DB because it is given D is the midpoint of AB. That means these both are equal. This is from given. So in this equation, in the place of AD, you write DB. So it becomes DB by DB is equal to AE by EC. This both gets cancelled. 1 is equal to AE by EC. If you do the cross multiplication, you will get AE is equal to EC. Nothing but E is the midpoint of AC. Therefore, E is the midpoint of AC. If E is the midpoint of AC, that means what? DE bisects AC. Hence it is proved. That is DE bisects AC. So in this way we can prove, children. Coming to the next important rider, prove that line joining the midpoints of any two sides of a triangle is parallel to the third side. This we have to prove using converse of BPT. Let us see this. In a triangle, what is given? D and E are the midpoints of AB and AC. That means AD is equal to DB, AE is equal to EC. That comes under given. We need to prove this DE is parallel to BC. Let us see the proof. In triangle ABC, D is the midpoint of AB. Why? That is given. So you can write AD is equal to DB. This you can write as AD by DB is equal to 1. Let it be first equation. In the same way, E is the midpoint of AC. E is the midpoint of AC. That is also given. What does it mean? If E is the midpoint of AC, you can write AE is equal to EC. This also can be written as AE by EC is equal to 1. Take it as equation 2. Observe these two equations. From 1 and 2, you can write their right hand sides are equal, no? So automatically their left hand sides are equal. That means AD by DB is equal to AE by EC. Now you see the step, children. In the figure you observe AD by DB is equal to AE by EC we got. According to the converse of basic proportionality theorem, if AD by DB is equal to AE by EC, we can say DE is parallel to BC. According to converse of basic proportionality theorem, it is proved. One more rider, children. That is ABCD is a trapezium in which AB parallel to DC and the diagonals AC and BD intersect at O. Then we need to prove AO by BO is equal to CO by DO. Yes, you see here I wrote given and RTP. A small construction is required. That is, through this point O, you draw a parallel line OX to AB. Then automatically this OX is parallel to DC because first these two are parallel. That's why if OX is parallel to AB, automatically this OX is parallel to DC. Let us see the proof. Now you take triangle DAB. In triangle DAB, OX is parallel to AB. That is from construction. If this OX is parallel to AB, from basic proportionality theorem you can write dx by xa is equal to do by ob. Therefore you can write dx by xa is equal to do by ob. That is equation 1 according to basic proportionality theorem. Now once again you see the triangle ACD. Observe, children, ACD. In this triangle also you can write OX is parallel to CD. I told you already, in the construction we have drawn OX parallel to AB, automatically OX is parallel to DC. So in triangle ACD, OX is parallel to CD. Since AB is parallel to DC. Therefore, OX is parallel to DC. Now, in this triangle also we apply basic proportionality theorem. It is given OX parallel to CD now. Then from basic proportionality theorem, AX by XD is equal to AO by OC. That is from basic proportionality theorem. Now, for our convenience, you take reciprocals on both sides and write in somewhat proper order. Here the reciprocal xd by xa. This xd I am going to write dx. This ax I am going to write xa. That is equal to, here also reciprocals OC by AO, that I am going to write CO by AO. Take it as equation 2. Now you observe the first equation and second equation. Their left hand sides are equal, so automatically their right hand sides will be equal. So from 1 and 2 you can write DO by OB is equal to CO by AO. From this you can write AO by BO is equal to CO by DO. Hence, next rider children, the diagonals of a quadrilateral ABCD intersect each other at O such that AO by BO is equal to CO by DO, then show that ABCD is a trapezium. This is just converse of the fifth one. Yes, take ABCD is a quadrilateral. This diagonals AC and BD intersect at O. I wrote here given and RTP. To prove this theorem, a small construction is required. That is, through this point O, you draw a parallel line OX to AB. That is our construction. Let us start the proof. It is given that AO by BO is equal to CO by DO. That is given. From this we can write this result as AO by CO is equal to BO by DO. Take this one as equation 1. Now consider the triangle ABD. In this triangle ABD, this XO is parallel to AB. In triangle ABD, that XO or OX is parallel to AB. That is from construction, because we did in the construction that one. Now in this triangle ABD, if XO is parallel to AB, then from basic proportionality theorem we can write dx by xa is equal to do by OB. Therefore, you can write dx by xa is equal to do by OB. Just take reciprocals on both sides. Here the reciprocal is xa by dx, that I am going to write as ax by xd, because xa or ax, dx or xd both are same. This you write as bo by do and take this one as equation 2. Now observe this first and second equations, their right hand sides are equal. If their right hand sides are equal, automatically their left hand sides are equal. Therefore, you can write from 1 and 2 equations AO by CO is equal to AX by XD. You see this one in the figure. AO by CO, that means OC, is equal to AX by XD. That means observe triangle ACD. In triangle ACD, you got this step, that is AO by OC is equal to AX by XD. Then immediately from the converse of basic proportionality theorem, you can write OX is parallel to DC. Therefore, OX is parallel to DC. That is from converse of basic proportionality theorem. In the construction, we have taken OX is parallel to AB. Now we got OX is parallel to DC. Therefore, immediately you can write AB parallel to DC. Because OX is parallel to AB and also OX is parallel to DC. So whenever you get AB parallel to DC, immediately you can say ABCD is a trapezium. Because in a quadrilateral, if one pair of opposite sides are parallel, it is called a trapezium. The last rider for today's session, children. In the triangle, in the given figure, if PS by SQ is equal to PT by TR and angle PST is equal to angle PRQ, prove that this triangle PQR is an isosceles triangle. See once, this is triangle PQR. It is given PS by SQ is equal to PT by TR and angle PST, this angle, is equal to angle PRQ. We need to prove this triangle PQR is an isosceles triangle. Coming to, first of all, you write in triangle PQR, what is given? PS by SQ is equal to PT by TR, that is given. Now you see, if PS by SQ is equal to PT by TR, then from converse of the basic proportionality theorem, we can write ST is parallel to QR. Therefore, ST is parallel to QR. That is converse of basic proportionality theorem. Now, if these two are parallel, then you can write this angle is equal to this angle because they are corresponding angles. Therefore, angle PST is equal to angle PQR. The reason is corresponding angles. Take it as equation 1. But in given, angle PST is equal to angle PRQ. But angle PST is equal to angle PRQ. That is given. Take it as second equation. Observe the two equations. Their left hand sides are equal. So automatically their right hand sides are equal. So from 1 and 2, you can write angle PQR is equal to angle PRQ. Once you observe these two angles, angle PQR, this, is equal to angle PRQ, this. These two are the angles in triangle PQR. So whenever these two angles are equal, immediately their opposite sides are equal. That is, PQ is equal to PR because sides opposite to equal angles are equal. Whenever you get the two sides are equal, therefore you can say triangle PQR is an isosceles triangle. Hence it is proved.